And now we have Ole Lensmar, someone who knows really well about the API specification, and who will share with us about how we can use OpenAPI to configure your own API gateway. So Ole knows a lot about OpenAPI documents and specifications, and knows a lot about gateways, and he will tell us how we can mix both.
Hey.
Hello, Ole. How are you?
Hi, Miri. Nice to see you.
Nice to see you virtually. Hope it will be in a physical manner soon.
Yes.
Love to have you. We heard about what you're trying to achieve at Kubeshop, and it seems that you're really one of the few who understand really both sides of gateways and OpenAPI specifications. We'd love to hear what you have for us.
Awesome. Thank you. Thank you so much. That's great.
You're not full screen. You're not completely full screen. We see your whatever.
That's okay. I'm going to be switching between things, so that's fine.
Okay, perfect.
Okay, great. Thanks so much. I was actually at Apidays Paris in 2016 and 2012, 13, 11. I don't know. I've been here a couple of times, or been there physically a couple of times. Now it's exciting to be here virtually. Yes, so I'm going to talk about how to use OpenAPI to configure your API gateway and why you might want to do that. And I'm going to dive into a couple of related complexities. I'm currently CTO at Kubeshop. I was the chairman of the OpenAPI initiative for many years, 4 years since it was in inception. Worked at SmartBear and been doing APIs for many years and all that kind of stuff. So I'm well familiar with all the space. And thanks to the previous speaker to also mentioning this talk. And we're going to see there's some overlap with actually what was shown there with what I'm going to talk about. So just to kind of get you started, this is a picture that you've probably seen, and a common way in that, the design first world of OpenAPI is kind of how OpenAPI can be used to drive the API lifecycle. So meaning that if you have a design first approach, you can then use your OpenAPI definition to generate mocks, as you can see up here to the left. You can generate code, as we just saw in the previous talk, right? Both clients and servers. You can use it to generate tests, as we also saw in the previous talk. You can do virtualization. Obviously, documentation is a big thing, developer portals, all that kind of stuff. You can use it to generate deployment and runtime related artifacts, and then client libraries for consumption. And I'm sure there's a bunch of arrows missing here, but I think you get the idea that having the OpenAPI definition as that source of truth in the lifecycle really enables you to really have a very powerful workflow. I'm going to be focusing specifically on the deployment runtime aspect of using OpenAPI to configure an API gateway, which is what you usually use to publish your APIs to the public. And I'm going to be focusing a little bit on Kubernetes, which is obviously gaining more and more traction today as cloud native computing, et cetera. It's been around for a while, but as it gains more and more popularity. So just to kind of recap, I'm sure most of you know, what does an API gateway do? API gateway is there to kind of expose your APIs to the world, act as a facade or an aggregation layer, depending on how you use it, right? So the basic functionality is to route incoming traffic to the APIs that you might have on the back end. And this is routing, mapping. You might add some quality of service related functionality like rate limiting or timeouts. Obviously, authentication is something that gateways usually adding cores, headers. And then if you go to more advanced features, security, orchestration of API calls in the backend, maybe you want to aggregate data from different API calls and even different protocols on the backend and just transform that and make it available to the consumer. Validation is another area. And this is where, if you look at all the API gateways out there, this is where they kind of compete and provide a lot of extra value add on that. And if you know OpenAPI as well as I do, and as many others, of course, you'll realize that a lot that you can configure in your gateway has an overlap with what's defined in an OpenAPI definition, specifically around your operations, the methods, maybe the security schemes, depending on the functionality of your gateway, the message format. And as you also may be aware that you can use extensions to OpenAPI to add additional metadata, right, for rate limiting and timeouts. There's a standard called SLA for OAS, which is about adding SLA related metadata. You can find that on GitHub. Additional security. And there's actually, if you go to the OpenAPI initiative, there's a bunch of special interest groups that are looking at specifically metadata for different verticals in the industry. So it doesn't even have to be operational metadata. It could be industry specific metadata that might speak to a certain a use case, or banking, for example, or healthcare, or what else. And wouldn't it be nice then if you could use your OpenAPI definition to configure your API gateway, right? So instead of having to do this another way, the OpenAPI definition already holds a lot of metadata to provide configuration for your gateway. And why would you want to do that? Apart from loving OpenAPI, well, maybe the biggest reasons would be that you would like to have one source of truth, right? And this is a common thing talked about in the API in many communities, not just in OpenAPI, but having one place where you define everything related to your API, right? So your functional aspects, which is what you define today in your OpenAPI definition, but also maybe your operational aspects, and like I'm going to go back to rate limiting, timeouts, security, metrics, other things that you'd like to be that are important to you when your APIs are deployed and in production. And the reason you might want to do that, having one source of truth, is it definitely eases collaboration, right? You have one place where everyone can go to, which obviously helps in a design-first approach. And it's common already today, right? You have architects, developers, engineering the operations and the parameters and the schemas. You have technical writers that are maybe adding, more descriptions and more examples that will then be used in your developer portal. And in the same way, you could have ops people adding metadata related to operational aspects. And another big reason here is what's increasing in popularity, especially in the Kubernetes world, is around automation and DevOps. And what this means is that if you have your OpenAPI definition of the source of truth, you can automate the configuration of your API gateway as part of your CI/CD, or if you're doing GitOps workflow. And the great things with that is that you're sure that your gateway is always in sync with your API, right? You know that I've added these operations, or I've changed some paths thanks to my automated workflow. I know that my gateway will be configured accordingly and not lagging behind or exposing the wrong things. And which in turn empowers your teams to be very iterative, right? They don't have to, they can make the change, they can push the change, and a minute later, depending on the efficiency of your pipeline, those changes are deployed in your testing or operational environment. So there's no need for other people to get involved and reconfigure stuff. And you could even go so far to use the OpenAPI definition to configure other things, right? Like monitoring or analytics or more adjacent services that are very specific to your setup. So it really comes down to helping you drive the lifecycle and the infrastructure around your API. And there's a couple of different approaches to this today. Let's walk through those. I think by far the most common approach, and if you look at most API gateways today, they have some support for this, right? You can go into their dashboards and you can import an API definition, and they will create an initial gateway configuration from there. But then what usually happens is that you add stuff to that, right? Then you import your definition, you get all your paths and routes configured, and now you have to then, using the tool that you're using, add the additional functionality and configure those. And this is obviously, it's super convenient and it's really easy to get started. The cons is that it doesn't always work with that iterative workflow. Let's say I've made a bunch of configurations. Now I've updated my API. Is it possible to update the configuration from my new API definition? And does it mean I have to reconfigure everything, or is the tool smart enough to be able to map my new paths to the old ones? And there's a lot of challenges out there. And I think some gateways are better at this than others. The other downside of this is, of course, the thesis I'm going for here is that OpenAPI is not the source of truth. It will be kind of a combination of OpenAPI and whatever you configure in the UI. of your gateway. And this is a super common approach. As I said, there's a lot of gateways out there, and I just put some names on here, didn't deliberately exclude or include anyone. It just, these things pop to mind from my experience. The second approach is that you would generate a gateway configuration from OpenAPI. Pros here is that you'd make your OpenAPI definition the source of truth, and you'd enable automation and an iterable development flow, and which would also be compatible with GitOps and Kubernetes. Cons is that you do need extensions that can describe whatever you want to configure, and you'd obviously have to run that generator whenever you need to update the configuration. And we just learned the OpenAPI generator, or Swagger CodeGen, which is have the same heritage, could definitely be used for this. As far as I know, they don't contain any official templates to configure any gateways, but they're super extensible, as we heard in the previous talk. So you could definitely use those, but you'd have to be coding. But I'm going to get back to this, because obviously I have something up my sleeve. And finally, what if you had a gateway that is configured natively from OpenAPI, right? So there's no intermediate step needed. OpenAPI is the source of truth. It'll support all those workflows. And as an extra bonus, the gateway could make use of the metadata that is in OpenAPI, right? For like functionality like validation or mocking or security, all things that the gateway could extract from the schemas and from the OpenAPI definition, and that wouldn't have to be configured by plugins or something like that. There's some drawbacks to this, as there are always, but I'm going to get back to this, and I'm going to rush ahead a little bit just because I don't want to miss out on some of the stuff in the end. So a lot of talk here. Let's talk quickly about Kubernetes and API gateways. And as Kubernetes, is an infrastructure and application framework. I'm not going to go too deep into that, but generally, if you're building an API that you're deploying in Kubernetes, if you want to expose that API to the outside world, you need something what's called an ingress in the Kubernetes world. And an ingress is more of a configuration, and then you need an ingress controller that actually takes that configuration and then uses it to expose your service, right? And there's a bunch of ingress controllers available for Kubernetes. Nginx ingress is the most common one. There's Ambassador, there's Traffic, there's service meshes like Istio that do this, and there's a bunch of others. And many of the API gateways today are also Kubernetes ingress controllers, right? So they kind of double that as that functionality, which is great. But on a technical level, ingress is the kind of the Kubernetes term, but you can still call them API gateways. And one reason for that is there's a couple of challenges related to ingress controllers. Is that Ingress specification itself is pretty shallow. No offense, but it's been around for a while, and it was created, as an initial way to expose APIs, and it lacks a lot of more advanced features around what you might want to need to do when you expose your APIs around routing, around quality of service related configurations. And it's being complemented or replaced by something called the Gateway API, which is a work in progress in Kubernetes world, which hasn't hit like a final release as far as I know yet. And because Ingress itself is rather limited, all of these Ingress controllers have their own additional file and configuration formats to kind of be able to provide all that extra functionality, right? So since Kubernetes is inherently configuration file driven, which means that everything you run in your cluster is configured by a YAML file that contains a manifest that you apply to your cluster. When you use these Ingress controllers, there's a lot of YAML to learn, right? And there's a lot of and they all do these things differently. So as you'll see in a little while. And so there's a lot to learn for developers as you kind of choose Ingress controllers, and you need to figure out, how do I do rate limiting, and how do I do this and do that. And there's also, just from a workflow perspective, pretty often it's the ops team who configures things in your cluster, right? And you don't, if you want to achieve an efficient workflow, you don't want to have to go to the ops team every time you make a change to your API. Hey, I've added a new operation, or I've changed the path here. I need you to increase the rate limit or so. Wouldn't it be great if you could do that without having to go to the ops team, which would update the configuration and apply that to your cluster? So there's a workflow contention issue or a challenge with Kubernetes. There's a bunch of great things, and you can automate a lot of these things, but it's something to be aware of. But to that end, wouldn't it be great if you could use your OpenAPI definition to configure your ingress controllers, right? You'd have one source of truth. You don't have to learn any more configuration files, and you have less YAML. Yay, who doesn't want that? So that's where the tool that I'm going to talk a little bit more about, Kusk, is coming from. So Kusk is an open source project that we're building at Kubeshop. It basically is a tool for generating ingress controller configurations from OpenAPI or Swagger definitions. And in that way, it makes the OpenAPI definition the source of truth, right, for configuring both functional and operational aspects of your API for your specific ingress controller. And today it supports Ambassador, Linkerd, Ingress Nginx, Traffic, and your favorite here, meaning that head over to GitHub, either contribute or open an issue, and we'll love to kind of expand the ecosystem of what we support and what we can do. And Kusk obviously uses what's already in OpenAPI to do basic configuration generation, but we do have an extension as well, an Kusk extension, which allows you to add metadata for rate limiting and timeouts and cores and a bunch of different things. And this extension is of course generic, right? So you write the extension once, and then Kusk will figure out how to translate that to the ingress controller that you're using. And this is kind of where you'll see the ingress controllers vary greatly, and specifically around like cores and rate limiting and things like that, how they are actually configured. So why would you use Kusk? And obviously you'd use Kusk if you're in a Kubernetes context, you're using an ingress controller, you want to achieve an iterative workflow. You realize that configuring and updating the ingress controller configuration is tedious. You have to learn a bunch of things. You'd like to only be able to work with your OpenAPI definition as the source of truth for both functional and operational aspects, and having one consistent approach. Also, Kusk obviously allows you to easily evaluate different ingress controllers, right? If you, for example, would like to, from a performance perspective, generate for different and just expose your API using them just to see kind of which one works better with your infrastructure. Also, Kusk enables a GitOps and CI/CD workflow, and this is a very Kubernetes specific thing. But a big thing in Kubernetes, as I mentioned before, is you managing all of this, the configuration of all your services in YAML. And GitOps is the practice of actually managing those YAML files in Git. And the result of being, if your cluster dies, you can basically recreate the cluster from the state that you have in Git. So, and Git becomes the source of truth for the entire configuration of your cluster. And there's a lot of advantages with that, what I just mentioned, but also all the workflows around Git with pull requests and audit logs, and RBAC is enforced on the configuration of your cluster. And so it's awesome, but I'm not going to talk too much about GitOps. With Kusk, though, you can achieve kind of a GitOps workflow for OpenAPI. So let's say you're working in your favorite tool for authoring OpenAPI definitions. This could be Postman, it could be Stoplight, Swagger Hub, your favorite tool here, or just an IDE. You update your OpenAPI definition to GitHub. A tool like Argo CD would then detect that you've created a new version. The tool would invoke Kusk to generate the new configuration for your ingress controller, and then compare that configuration to what's already running in your cluster and update your cluster accordingly. So from the time that you make your change and push it to GitHub, 30 seconds, a minute later, your cluster and your ingress controller will be configured and up to date with the changes that you made automatically. So this really opens up for a really iterative and powerful workflow. And it's super cool. Okay, so a lot of talking. Sorry about that. Just wanted this stuff, a lot of things I wanted to get through. So I'm just going to do a really, really short demo of Kusk, and I'm gonna use a couple of tools here just to show you. I'm going to start by just generating using the Swagger Pet Store version 3. So this is the vanilla Pet Store that you download from the online Pet Store, and generate a configuration for Nginx Ingress. And I'm going to jump over here to this other tool called Monocle, just to show you kind of what was generated here. And this was a super basic manifest that I could now apply to my cluster. And if I did that, and I had PetStore running in my cluster, I would now be able to access PetStore from the outside world. Just to show you the PetStore, this is the actual PetStore YAML file that I've been generating from. So that wasn't maybe too overwhelming. Let's have a look if we want to generate for another tool. So for example, for Ambassador, going back here, we'll see that Ambassador instead doesn't use the Ingress specification at all. It has its own mapping configuration format. Just one file needed when we do such a basic thing. I'm going to show foot traffic as well, which is kind of reasonably common. Back here is your traffic. This actually generates two files, one which is rather lengthy, and a server transport file, which is rather short. But ultimately, as you can see, I only had to run Kusk for these different files for different Ingress controllers and just generate these basics. So this was a somewhat simplistic example. So let's look at what will happen if I actually use some of these Kusk extensions. I've taken the PetStore v3. I've added an extension here with rate limiting, timeout, some core settings, and I've also added a tag, sorry for scrolling, who doesn't love a little bit of scrolling in a demo, a Kusk extension to disable certain operations. And the reason, this is actually pretty common, that you might have an API where you don't want to expose everything outside, right? You might have some operations that are either not done or they're administratively, they're admin operations, so you don't want to expose them, for whatever reason, you want to hide them from the outside world. So there's an extension in Kusk to do that. So now let's go back here and generate corresponding, let me see here. So this was called ext. Start with traffic here. The traffic now ends up with generating 4 files for the cores, rate limiting, and the PetStore. So it wasn't such a huge difference, I guess. But if we go back to looking at, let's see here. Ambassador, for example. So for Ambassador, we actually get a whole bunch of files, and this is related. These are all the mappings for the individual operations, and then there's rate limiting configurations for each of them. And you can also see in here that the timeout has been added, and that the core setting has been added in a Ambassador specific way, right? And then finally, which one did we do? We did traffic, Ambassador. We'll have to do Ingress. Point of. So here now you'll see that for in your next, it'll generate a bunch of operations. And these operations are referring to a PetStore service, which I don't have locally, which is why I'm getting these small errors. So this is totally fine. And you can see here that Ingress actually uses annotations for many of the cores and our rate limits and all that kind of stuff. So you can, just by this super short, I'm not going to show anything else. Just what I wanted to illustrate here is how different the configuration is for the different Ingress controllers, and the beauty of having one source of truth, right? The OpenAPI definition to be able to generate all those different configurations, having Kusk doing all the heavy lifting when it comes to differentiating and things. Okay, and I'm out of time. I'm just going to go back here really quick. Sorry about that. Last thing I wanted to talk about, Kusk Gateway is the last thing that we've just launched at Kubeshop. So this is an OpenAPI first gateway for Kubernetes. And it's built on Envoy, and it works for both standalone local development. I'm sorry, since I'm out of time. Why would you use this? It makes the OpenAPI definition your source of truth, and it gives you all the goodness of the things that I've talked about earlier in the talk. And I'm sorry about rushing ahead, because I talk too much, as always. Thank you so much for watching. Head over to our booth if you want to see demos, and go over to our Discord channel or GitHub, and let us know what you think. Obviously, we want to see people using this, and we'd love to hear how it could be of help. Sorry about talking too much. Mehdi, back to you.
It's okay. We just run a really quick question. Recently in the API community, we've heard the word API ops, like API into DevOps, and how we can use DevOps for let's say API management. So it seems we're there.
Yes, we're there. Yay, finally. No, but definitely, I think, especially once again, with this configuration-driven nature of Kubernetes, I think there's definitely a huge opportunity for automating operational workflows around APIs. And so that's kind of where Kusk is. And you could use other tools, OpenAPI Generator, the Swagger CodeGen that we heard in the previous talk to achieve that. And I'm sure there are other great ways of doing that. But we are definitely getting there. And I think that's super exciting because it does really, once again, empower these iterative and rather efficient workflows around developing APIs.
Yeah, and it's true the term API ops was a little bit like at the beginning was just a concept and an idea, but now we see more and more tooling to really make it happen. Kubeshop is one of them. Thank you very much, Ole.